Hello, everyone. Welcome for our next session. 150 must-do questions. I think with the let's say around 50 days only or so that we are left with. Right. So part 12, 150 must-do questions. Okay. So as always, I have endeavored to bring forth the most innovative and the most I would say also a little challenging questions. Okay, something which is thought provoking, I would say, if not challenging. Okay, the idea being we should be exposed to point number one, the most often asked concepts. Point number two, the most innovative new kind of thing, right? Because let's say if I'm facing any exam in any year that we face, the cat paper, depending on our practice, right? Let's say around 60 to 70% of the questions on an average can seem familiar, but there is always that 20-30% spectrum of problems which are new for us, right? So we should be exposed to them, those questions which make us think in new ways, isn't it? So just shout out to me, everybody who is there. Hello, hi, everyone. Should we start? Yes. And stay in touch. I'm actively looking on your chats. All right, so let me set up the agenda again. That in this session we have brought, let's say, some new kind of problems and also some often tested concepts. Okay, it's a mix of all the things and across all the topics, because obviously with the around 50 days left, this is the time that we should be just doing practice in a mixed manner, right? You should have been giving full length tests regularly, as well as some sectional tests also from time to time. Okay, so I did not receive any hello, hi, yes, just a shout out that from people who are in the session, right? Because that's the only way I can understand that you are there. So, uh, right, waiting for your hellos. Yes, you are there, so that we can start up. Hmm. Okay, I'm assuming that perhaps you're not taking some time, but just let me know. Okay, so therefore, here we go. Right. Uh, Let me say one thing that I would start discussing the questions immediately. Right. You can either solve on your own, okay, or follow what I'm doing. What I would suggest is I'll give you a minute to look at the problem, okay, understand what it is all about, get some sense of it, and start doing it. Okay, so try to beat me in your process. Okay, try to get the answer faster than I can announce the answer, right? So those people, their names will be announced all along the way. Okay, so therefore, here we go, people. Let's start. All right, now, so this is the first one. Topic is already also mentioned above. uh, Giving you a minute to digest this question and start trying this, and then we'll discuss after a minute. So while you are trying, let me start writing some basics. Names, at least let me note that down. So, right, Kriti, Bharti, and Aditi, right? And we are having 2023. So 23, 24, 25. Remember, the task is you should be better than me. Okay, so solve this question faster than I can. Right? Share your answers on the chat box. Let me know you are actively participating. Okay, time's up. I mean, enough time given for you to try. Now, just try to finish it quickly and let me know if you get the answer, right? Now, here it is. So these three people, the incomes of Kriti, Bharti, Aditi were in this ratio, this ratio. So 3 years, three ratios we are given, right? Okay, so let's note down them. So it's 9 is to 5 is to 7. So if this is 9 something, this is 5 something, this is 7 something, right? So 9x, 5x, 7x. Now I'm not writing the variable because I just want to directly work with the numbers. Okay, that would always be a good way to do. Then 6 is to 3 is to 5 in 24. So 6 is to 3 is to 5, right? Ideally, I should write 6y, 3y, 5y, right? That is 9x, 5x, 7x. But I'll solve this question without any single variable. Look at this. And 434 is here, right? 434. Perfect. Now, so now look at this. Total income of Bharti and Aditi, right? In 2023, which is 5 plus 7, 12 into something, matches to Kriti's income in 24, which is 6 into something, which also matches to Aditi's income in 25, which is 4 into something. So these three are the same. So 12 is the same as 6 into something. We know 6 into 2 is 12. Is the same as 4 into something. We know 4 into 3 is 12. So can I say I need to multiply the numbers in the second and the third ratio with 2 and 3. Finally, Atrey Dasgupta, thank you. Very well done. Yes, thank you. Good. Good, good, good. Finally, yes, one person has got the answer. Very well done. Right. So, yeah, so I think I'm also about to finish. Right. So the point is, whatever are equal, so, just write the numbers in a way that the condition is satisfied, basically, right? So, what we have over here is that we need to multiply the numbers in the second ratio with 2 and the numbers in the third ratio 4 is to 3 is to 4 with 3, so that the condition will be justified, right? So this 6 becomes like 12, right? I'll just now cancel 6 and write 12. 3 will become 6, 5 will become 10, and these numbers in the third ratio will be multiplied by a factor of 3. So this will be 4 into 3 12, 3 into 4 12, and 4 into 3 12. So now these numbers are now all interconnected, right, with this condition, right? Means when I had just written the first time I had written the numbers were connected only in the row wise manner, right? That was 9 is to 5 is to 7. This was 6 is to 3 is to 5. But that 9 and this 6, we did not know the correlation. Now I have correlated the numbers across the uh, columns, right? So therefore, now we can verify that which of the following statements is not true. Atrey has already declared the answer. It is yes, so it is D. Right? You can easily check A, B, C are all correct. Right? D is the correct choice because D is not correct. Kriti's income in 2023 is like 9K. Okay, that does not match with Aditi's income in 2024, which is 10K. Right? So they are not the same. This 9 and this 10, they are not equal. So therefore, option D. All right. Good, good. Whenever you respond, right, that makes my day. I mean, I get to know that, yes, you are active and you want to get it done, right? Thank you. Okay, next one. All right. Again, I'll give you a minute or so. And any confusion, any doubts, do let me know. The whole point of this live session is that you can ask me anything. All right. All right. Okay. So while you're doing, I hope you reach to the answer and do let me know now. So here it is. So there is milk and water, right? And 40% of the mixture is removed and replaced with water. So since I'm pouring in water, so obviously the concentration of milk is going to decrease, right? So it is given that the resulting solution contains as much milk as the original quantity of water, right? Before we did our removal and replacement. Okay, so since the total volume of the solution is not given, okay, I'll again do this question with no variables, just numbers, right? That's always what is, easier to understand and digest, right? So I'm taking the total volume of the initial solution as 100, right? Initially, I'm taking the volume as 100. So how much was milk? Don't know. Right, that's what we have to find. So let's say that is x, right? So therefore the remaining was water, which is 100 minus 6. Perfect. Now, so therefore what happens is, when we do removal and replacement, r and r, right? So what happens is you're removing 20% of the solution, for sorry 40% of the solution. Okay, so therefore when you remove 40%, so what remains is 3/5, right? So you're left with 3/5 of each, which is you're left with 3/5 of you're left with 60 of the solution, right? And you're left with 3/5 of x, and you're also left with 3/5 of 100 minus x. That is what remains. And now you're replacing that with water, right? So first removal and replacement happens, and now this is removal actually. I would say this is I'm breaking this into two parts. That this is your removal process, right? You have removed 40%, and now you're replacing. So what you're doing, you're adding just water. So this water becomes 3/5 100 minus x and plus 40, right? And this remains as it is. You did not pour back any milk. So what is given is that the resulting solution contains as much milk. So milk is 3/5 of x as the original quantity of water, which means this 3/5 of x matches with that initial quantity of water, which is 100 minus x. I can again see Atri has given the answer by now. Thank you, Atri. Others also try to join in and right, show your metal, right? Okay, so therefore this gives us the value of x. So 3/5 of x equals 100 minus x. That is the relation from the condition in the problem. So x comes here, 3 by 5 plus 1, which is 8 by 5 of x is 100. So x is coming to be 100 into 5 by 8. And we have to find the concentration of milk originally, which is coming to be this fraction only, na? 100, 5/8 of that is milk. So 5/8 means 62.5% is your milk, right? In the original solution. Perfect. So I think quite a manageable one, isn't it? So see, the in any question, the point is, as soon as you look at the question, what is the first step that you think has to be done, right? So mostly what I try to do is, now I want to like minimize my like reliance or dependence on the variables, right? That's what I mostly try to do as much as possible, right? Sometimes the questions are really complex and do require variables, but as you can see so far, I have done mostly with very less usage of variables. Only one thing I took, okay, out of 100, let's say milk is x, right? Otherwise, one variable is, I would say, not too much of a hassle, but beyond that, sometimes becomes little more tedious task, right? Okay, here we go. Next one. What about this one? Right? Quite a lengthy one to read also. Let's see. Okay, so I'm diving in here straight away for the reason that mm, I want to give you okay, let me give you a minute to try. Let me give you a minute to try. That won't be helpful for me to straight away start doing this. Giving you a minute to try this. All right, let's do this as well. so quick. Prabhakar is saying B. Oh my god, I think Prabhakar has a better solution than me because you got this very quickly. Yes, Prabhakar, that is correct. I'm very happy. Uh, now, so therefore, I need to start now because one person has already declared the answer, and that is too correct. So, Prabhakar, I'll do this and just let me know when I'm done. That do you have a better explanation than me? Right? Maybe that I would like to know. Okay, so here is what I would do. So you can understand that in this question, what is happening is that the efficiencies or the work rate, right, of the persons are either some percentage more or less than their usual rate, right? So you need to assume the work rates of the two people A and B as some variable, obviously. And in order to write some equations regarding that, you need to quantify the work first of all. In any time and work question, the first step is to give some assign some numerical value to either the work rate or the total work. In this case, since work rates are two independent ones, so I need to take them as variables. And using the LCM concept, I will define or I will assume the total work as the LCM of the time periods mentioned in the problem, which is LCM of 150 here, 150 days, and this is 160 days. Right, so that would work out to be 2400. So I'm taking the total work as 2400 units. I'm taking work rates of the two people as small letters A and B respectively for the persons denoted as capital A and B. Right, now I will write the equations regarding this. Okay, so here we go. So work is rate into time. Right, work is rate into time. So in the first case, A reduces his efficiency by 20%, and B increases by 20%, and the project is completed in 150 days. So work, which is 2400, is equal to rate into time. So rate is work upon time. So rate will be how much? See, I'm writing the equation for the rate achieved on a per day basis, right? So rate achieved on per day basis was how much? This is obviously you have to assumed A and B units per day as the work rate. So 20% less, A reduces its efficiency by 20%, which is 1 by 5th. So 1 minus 1 by 5th, which is 4/5 of the usual rate. So 4/5 of A plus B increases by 20%. So 1 plus 1/5, which is 6 by 5 times of the rate of B. So that is equal to work upon time, which is 2400 upon 150, which is 160, right? So this is my first equation. Let me simplify this further. 5 goes there, so 4a plus 6b equals 16 into 5, 80, and 80. Just let me check one second my calculation part. I took the LCM as 2400, right? 15 into 16 is 2400. So 2400 by 150 would be actually 16, right? 16, not 160, but 16, right? So 4a plus 6b is coming to be a. This is 16 into 5, 80. So I'm getting finally my 2a plus 3b to be 40 is my first equation. Likewise, for the second scenario, we'll write another equation. We'll get another equation on A and B and we'll solve that. So A reduces the efficiency by 50%. So half is his efficiency, simply A by 2, plus B increases efficiency by 50%. So it becomes 1.5 times or 3 by 2 times. So 3 by 2 of B is again 2400 work upon time, which is 160, which is 15. So we are getting that A plus 3B is 30. First equation, second equation solve. Simply subtract, 3b cancels. So 2a minus a, which is a is coming to be 10. Put it back. So 3b from the first equation is 40 minus 2a, which is 2 into 10, 20. So 40 minus 20 is 20. B is coming to be 20 by 3. So with A and B obtained as well as the work defined, answer can now be obtained. How many days would they take to complete the project if both work at their usual efficiency? The usual efficiency means now the work rate is simply a plus b, the normal way it should have been in the original place, right? Which is nothing but 20. A is 10 and b is 20 by 3. So 10 and 20 by 3 is what? 50 by 3. So therefore, finally, the total time taken in this normal scenario would have been the work, which is 2400 units, divided by the rate, which is now 50 by 3, which comes to be 50 cancels, and yeah, so goes away, and this is 48, right? And 48 into 3, which is 144 days, right? That's your answer. Atray also got this eventually. Prabhakar also got this, right? But Prabhakar gets higher points because he got very quickly. All right, good to see that people are trying along with me, right? Any doubts, do let me know, else we should move on. Everybody clear? All right, right, okay, here we go. Next one, geometry, and the figure is also given. All right, so very interesting one. Again, let's see if you can get this. Okay, I didn't solve, just use the fact that if reducing A's efficiency results in increased time, that means A was doing most of the work. Now when A and B work at their normal efficiency, time should reduce. Okay, so very good. Prabhakar got the answer just by observation. He did not go through the whole process of solving. Kind of, kind of informed. I mean, you can say optional elimination. That's what he did. Thank you, Prabhakar. Very good. Very good. So let me go back. Something he's giving us a very good insight. Hmm. All right, all right. Good. Okay, now let's see this one. Ah, okay, so I let me give you a few more seconds to try. Let me see if you get this. Okay, because I know this question requires little bit calculation part also. Okay, so I think enough time given, and if you are about to finish and you get the answer, do let me know. Now here it is. So first of all, this question is completely the one in which symmetry should be observed. There's a rotational symmetry, okay, which means that consider the one square as square x, the other as square y. If I rotate square y by 45 degree, I'll get the same figure as if I had rather rotated square x by 45 degree. So the point is, all the parts that you see on the sides, right, which means these right triangles that you can see over here, obviously these all are right triangles, right? They should all be congruent. They should all be congruent. And also because of the symmetry, these lengths should be the same. If this is x, this is also x, this is also x, has to be, because of the symmetry, right? So in geometry, symmetry is something that you observe, right? You need not prove to anybody, okay, why is this x x x all the same? It has to be because of symmetry, because of the way it is framed, because they're two identical congruent squares and you're rotating them in a way which aligns one with the other, such that the angle 45 degrees seen everywhere, right? So these right angle triangles are not only right angle triangles, they are also right angled isosceles triangles. They have to be, because these x x x all have to be the same, right? Now, so the point is that we have to basically see that, from the original square, we are eliminating these four right angled isosceles triangles and in the corners. So what percentage does that make out to be, right? Which has to be removed from the whole square. Now, in terms of this variable x that I have taken, can we define the side length of the square? If we can do that, then that is target achieved, because we need to find the area of the shaded part as a proportion of the area of the each square. Or in other words, the complementary thing is to find the area of these four right angled triangles as a percentage of the area of the whole square, for which we need to express the side length of the square in terms of x. For which you can now see that the side length, let's say from this horizontal direction, this is x, this is also x, and this part that you can see over here is the hypotenuse of a right angled isosceles triangle whose other two sides are x and x. So this much becomes root 2x. So your side length, let's call that a, comes to be what? X plus x, which is 2x, plus this root 2x. So I think our job is mostly done. Only calculation is remaining, right? So therefore, we can now finish this off. A has come to be 2 plus root 2x. So therefore, what is the area of, you can say, the removed area from the square, right? Which is the area of the four congruent right angled isosceles triangles, right? So we can find their combined area. So from 100%, this much percentage area is removed. How much? So removed area is 4 times 4 right angled isosceles triangles of half base into height, half into x into x, which is simply 2x square. So therefore, the percentage of area which is removed from these four corners, these four right angled isosceles triangle, is your 2x square whole upon simply a square, and a is 2 plus root 2 times of x. So now you can finish this calculation. So 2x square over 2 plus root 2 the whole square into x square. So what is 2 plus root 2 the whole square? I'm directly writing here, right? That is what we'll have. So 4 plus 2, which is 6, plus 2 into 2, 4 into root 2, which is 4 root 2 x square, right? 2x square completely goes off. 2 also cancels, x square also cancels. I'm left with simply 1 over 3 plus 2 root 2. Now I need to calculate this. This is a fraction of area removed. So rationalize this. 3 minus 2 root 2 by 3 minus 2 root 2. In the denominator, you will have 1. 9 minus 8, 1. A plus b into a minus b is a square minus b square. Rationalizing. So I'm only left with 3 minus 2 root 2. Now I need to calculate 3 minus 2 root 2. I know root 2 is 1.414. So this is 3 minus 2.828, right? So the percentage of area removed is coming to be 100% into 3 minus 2.828. So this is 100 into, this is 0.172. So this is approximately 17.2%. And therefore my answer is 100 minus 17.2%, which is 82.8%. Nearest option 83 is the correct choice. All right. So, well, Finally, I think this question stumped everyone. But did you get my point? In geometry, making use of symmetry is the key. All right. Perfect. Moving on. Next one. Any confusion? Any doubt? Anything? Let me know. Next, here we go. Sequence and series. Okay, fine. Again, let me give you a minute. Shubham, in this question, this is the original square, which I'm now highlighting, right, Shubham? This is the original square. So now can you see that those those four right angle triangles are not part of the original square? They have been generated because of the rotation of the other square. They are out of the boundary. So from the original area A square, we only need to remove these four right angle triangles and not all of the 8 ones. Right? Removing from A square, these four right angle triangles makes up for the shaded gray region. Right, Shubham? I hope it is clear. Now you can see this. All right. Okay. Now, so sum to infinite terms of this series. Uh, I think yes, Shubham. Visualization is required, right? Yeah. What is the sum to infinite terms of this series? Options are quite close, isn't it? So guessing is not something that is possible. Mostly because what happens is in these kind of questions, what people do now, they sum up the first few terms and get to see what is the approximate sum of first few terms, and they guess that that is the approximate infinite sum also. But in this case, options are quite close, so not possible. We have to solve it properly, right? Okay, so timeout. If you get this, do let me know. I'm starting to discuss. Let's say the sum is, I'm calling it A. Okay, let's say A is the sum which is given. First of all, I hope everybody has understood the pattern in the sequence. Numerator we have odd numbers, denominator we have powers of 2, right? So the general term is something like, you know, Tn, the nth term is something like 2n minus 1, odd numbers in the numerator, and 2 power n, powers of 2 in the denominator, right? These are the general terms, right? Now, so therefore, this is the infinite sum. We have to find this. So in all such questions where you see, there's a mix and match, some logic of GP is also there because there is 2 power n. So that is a GP, and 2n minus 1. So that's an AP. So it's a mix of AP and GP. So in these kind of questions, whenever you see some element of geometric progression along with some other coefficients which are going in some different pattern, write the expression. uh, okay, so somebody has given the answer. Yes, Anand, that is correct. Thank you. Thank you, and I got it. All right. So, yeah. So the concept is whatever is your common ratio of the geometric progression, right? Multiply this equation with that and write the terms in a shifted manner, which means I'm multiplying with half on both the sides because that is the common ratio. Uh, I understand your point, Shubham. Basically, you can correct this if you want to write this properly. You can write 2 power n minus 1. You want to properly, if you want to see, nobody's asking a formula for that. Okay, it's just that to understand the logic, I've written odd numbers. So whether you write T0, T1 or not, that is all up to you, right? Normally the convention is T1, T2, T3. But questions have been asked, we have seen in the recent years, where the problem mentions first term as T0. So when the question mentions it, so we'll use it. As of now, it's just for our own understanding. I'll just follow T1, T2, T3, right? So with that, this formula is valid because putting n equal to 1 gives you 1 only, right? Putting n equal to 1. So now what we'll do, we'll multiply on both the sides with the common ratio, which is half, and shift the terms, right? 1 becomes half, right below 3 by 2. 3 by 2 becomes 3 by 4, right below 5 by 4. So now we can take the differences and get it simplified. 5 by 4 is 5 by 8, 7 by 8 is 7 by 16, and so on. And now, obviously, subtract, so that your coefficients now become simply constant, right? A minus a by 2, which is a by 2, equals 1 plus 3 minus 1, 2 by 2. Don't write 2 by 2 as 1. Don't do that. Because there's a pattern now, 2 by 2. And then again 5 minus 3, 2 by 4. 7 minus 5, 2 by 8. 9 minus 7, 2 by 16. So now this has become a standard infinite GP, a standard geometric progression. So this is 1 plus 2. 1 is a separate term. Okay, that's a separate term, not part of the geometric progression. And then 2 is common in the numerator, so 2 into bracket 1 by 2 plus 1 by 4 plus 1 by 8 plus dot 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 infinity. So this infinite sum we know is a over 1 minus r. The normal infinite sum of a GP is a over 1 minus r, a being the first term, r being the common ratio. For this sequence that I have written here in the bracket, the first term a is also half and the common ratio r is also half, right? So this becomes 1 plus 2 into a over 1 minus r. So half over 1 minus half, which is nothing but half upon half, which is 1. So this is coming to be 1 plus 2 into 1, or 1 plus 2, which is 3. And this 3 is the value of a by 2. So a by 2 is 3. So a is 6. Right? So 2 people got this. Anand also got this. Atri also got this. Thank you. Perfect. Okay, so this is a usual one, right? I think mostly people know this trick, and for those who do not know, should know this. Okay, now next one. PNC. Okay, PNC is everybody's favorite topic. I mean to say, let's see if you get this. It's a theta one. No options to help you this time. Okay, so try this. Let's see where you go. Shubham, if you're asking for the last question, which is the sequence one, then what is the logic is multiply on both the sides. I mean, write first of all the sum as a, and put it as any variable. Then multiply on both the sides with the common ratio. The common ratio is half. So doing that and shifting the terms by one step, so that when you take the differences, you get a constant term in the numerator. So that is the trick, right? So you get the standard geometric progression after right, multiplying on both the sides by the factor of half, and writing, 1 becomes half, you write below 3 by 2. 3 by 2 becomes 3 by 4, you write below 5 by 4. So that next time when you take the difference, taking the difference gives you This 2 by 2, 2 by 4, 2 by 8 becomes a standard GP. Right, Shubham? Okay, so people, are you trying this one? Okay, right. So I've given you time. Let's see if you get this. Let me know. Now, here is what it is. The CM must open the floor, right? Everybody has read the question. The CM is always fixed as the first person to open the floor, right? The CM must open the floor, followed by MLA with at least one speaker between them. And MLA must speak before the governor with at least one speaker between them. So what we can do is, apart from these three people, the other five people don't have any restriction. So CM is also fixed. What we can do is we can just count in a sort of a manual way what is the combination of position numbers for the two remaining people, MLA and governor, right? Once we do that fixing or the counting of their options, then the job is almost done, because the other five people will freely get arranged in without any restriction in 5 factorial ways in the remaining 5 places, right? So the answer is simply 125 factorial times the number of ways we can assign the positions to the MLA and the governor. CM is already fixed, right? So first position is gone to CM. MLA can never take the second position, because he can, at least one person needs to come after CM also. So MLA will start getting the positions from third position and onwards. So we'll count from there onwards. If MLA now gets the third position, so I'm writing the positions over here, right? So governor cannot be fourth. He can be fifth, sixth, seventh, or eighth. So from 5 to 8, he can have 4 ways. Yes, Atri, correct. Thank you. Right? 4 ways for MLA and governor to be assigned the places if MLA is taking the third place. What if MLA takes the fourth place? Then governor cannot be fifth. He can be sixth or seventh or eighth. So 3 ways for governor. If MLA is fifth person, then governor cannot be sixth. Right? He can either be seventh or eighth person. 2 ways. This is the number of ways that I'm writing over here. Right? And finally, because after this MLA cannot go further ahead, so MLA can take the sixth place, then governor can only take one place, which is the eighth place, only one way. If MLA is seventh person, then governor will not have a feasible option, because he can only be the eighth person now, and then he'll be adjacent or just the next person after MLA, which is not allowed as per the condition. So 4 plus 3 plus 2 plus 1, which is total of 10 ways that these two persons can be assigned their positions. So therefore, overall, the total number of ways, as I was saying, as I've already mentioned, that 10 ways for assigning the positions to the MLA and governor, CM is already fixed, into arrangement of the remaining 5 people. Remember, there are 8 people, 8 speakers in total. So those remaining 5 people can be freely arranged in the remaining 5 positions, always in 5 factorial ways, because n objects can always be arranged in n positions in n factorial ways. That's your basic of PNC. So 10 into 120, which is 1200. Thank you, Adri. All right, so this was this one, somewhat new style of a problem, right? Okay, next one. Okay, here we go. Now let me take this one. I brought a very unique kind of a question in today's session, which is this one. Okay. So questions on geometric counting have been asked in the past, right? Questions are such that, moving along a grid, how many ways you can move along a grid, kind of questions have been there. How many ways, how many lines can be formed using some points, those kind of questions have all been asked. This is also something to do with points and lines and rectangles, right? So geometric counting, right? Counting of geometric figures and shapes formed using uh, points and lines and their counting. So geometric counting, it's an overlap of geometry and PNC, right? Okay, so uh, let me take this one for you, something new. 6 parallel lines, each 1 centimeter apart, are crossed at right angles by 8 parallel lines, each 2 centimeter apart. So you have to be careful with the geometry also. 1 centimeter apart, 2 centimeter apart. How many rectangles with unequal length and breadth are formed by these lines? So I'm trying to draw this figure first of all to understand, because we can only understand with some figure. So I'm drawing some 6 parallel lines first of all, each 1 centimeter apart. Okay. So let me do that here. Okay. Looks like that. Okay. Now these lines now are crossed at right angles by another set of 8 parallel lines. So this is a gapping of 1 1, and now the spacing for the next lines are 2 centimeter apart. Okay, so right, 1 2. I'll not be able to draw all of them, right? Otherwise all of my screen will just get overloaded with the figure only, and dot dot dot. So there are 4 more lines proceeding this, right? Okay, so therefore what we have to do, what we need to do, we need to find the rectangles with unequal length and breadth. So the point is we have to remove the squares from the rectangles. Now finding the total number of rectangles is quite straightforward, because to form a rectangle you have to choose 2 amongst the 6 horizontal lines and 2 among the vertical 8 lines, right? Once you choose 2 lines horizontally and 2 lines vertically, you have chosen a rectangle, you have created or you have formed a rectangle, right? For example, let me illustrate. Let's say I choose horizontally this line, I'm marking over here this line, and I horizontally choose, let's say, this line over here, and vertically let's say I choose this line, the very first one, and let's say this last one. Okay, so I'll be basically forming this rectangle, which I'm now shading this one, this rectangle I have chosen, right? So every time I'm choosing 2 horizontal lines and 2 vertical lines, every time that I'm choosing a different set of such pairs of lines, I'll be choosing a unique rectangle. Yes or no? Yes or no? Right? For example, as I will illustrate over here. So therefore 6C2, that you choose 2 among the 6 horizontal lines, into 8C2, that you choose 2 among the 8 vertical lines. So that is the total number of rectangles, right? So that we can calculate. 6C2 is 15, 6 into 5 by 2, right? So 3 into 5, 15. 8C2 is 8 into 7 by 2, so 4 into 7, 28. 28 into 15, which is 420, is the total number of rectangles. And that is not your answer, because amongst these rectangles there are some squares, and you have to remove the squares from these. Again, Atri, correct? Atri has got this. Prabhakar, just check. Right, I'll do this for you. Good, Atri. Now, so therefore, yeah. So now let me count the rectangles for you. Squares, right? Squares. Now comes the geometry part over here, right? This is the spacing of 1 1 each, and right, and this is the spacing of 2 centimeters each. So since this vertical lines are 2 centimeter apart, the square can only be of size which are in terms of multiples of 2. Like you can have a square of size 2 by 2 or 4 by 4 or 6 by 6. No, 6 by 6 is not possible, because you can see that in total the horizontal lines are spaced at a maximum of 5 units only, 5 centimeters only, right? So there are only two dimensions of squares. One will have 2 by 2 squares, one will have 4 by 4 squares. We just need to count them, right? So how many 2 by 2 squares are there? We need to count them. How many 2 by 2 squares? So you need to choose, let's say, first of all, the horizontal lines. Okay, let me label the lines as line number A, B, C, D, E, F. So horizontal lines can be chosen as A, B, sorry, AC, 2 centimeter 2 centimeter apart. So this is 1 plus 1. I need to take 2 centimeters apart. So A and then C, right? Leaving 2 centimeters. And likewise BD or CE or DF, right? So 4 ways to choose the horizontal lines. For vertical lines, again, if I just label these lines as simply L1, L2, L3 up to L8, right? So either L1, L2 or L2, L3, and dot 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 in the last we'll have L7, L8. So obviously this is, 7 options because you're starting from L1 finishing at L7. So 4 into 7, because 4 options for choosing the horizontal lines and 7 options for choosing the vertical lines. 28 rectangles are squares. So this has to be removed. And coming to now 4 by 4. So horizontal lines 4 centimeter apart. So A and then E, right? A and then B, C, D, E, or B and then F. And from the vertical, you can choose this L1 and then L3, right? L1 and then L3, or L2 and L4, and so on. In the last, we'll have L6 and L8. So these are 6 options here. So this is 2 into 6, 2 options for horizontal, 6 options for vertical lines, 2 into 6, 12. So 28 and 12, 40 is your squares. So answer becomes 420 minus this 40, which is 28 plus 12. Your answer is 380. Right? So very innovatively, geometry was properly required, right? Because okay, how will we form the squares? 1 1 1 here, 2 2 2 here, right? So something unique, geometric counting, right? So PNC is also applied in such ways. Interesting. I hope this is clear. Can we move to the next one? Okay, let's see. Here we go. What's there? Oh, percentage. So just to refresh our mind, let's come back to something on arithmetic. Let's try this. Right? I think arithmetic always refreshes us, isn't it? Okay, so I want maximum response on this one. Last few questions have been a little heavy, but I'm giving something interesting now. I mean, very doable. Everybody should try this. Okay. Now you don't even have options. Oh, Prabhakar got this. Prabhakar got this. Very well done, Prabhakar. I'm so happy. I'm so happy. Very good. Thank you. Clapping, clapping. Good, good. Atri also got this. Good. Thank you. That is reward for me. Okay. Thank you. So yeah, right, so I'll just discuss this for everyone, right? Income is expense plus savings, right? Percentage changes or ratios are defined between all these three parameters across 2 consecutive years. Income is always expense plus savings, right? From the last year to the current year, what happens to the salary or the income? It rose by 2/3, right? It rose by 2/3. So 2/3 is a fractional growth. So it gets multiplied with a factor of 1 plus 2 by 3 or 5 by 3. Or simply the ratio of the income of the current year to the last year is 5:3. So if this is like 5x, let's say, then this is 3x. Okay, by the way, I'm discussing this from my style. Okay, if anybody has a better approach, I would want to hear your approach. Okay, so just look at how I'm going about this. Expenses, right? For people also who have solved this, just do let me know by the end of it if you have a better way. Okay, his expenses grew by 80%. 80% means 4/5. So if it's grew by 4/5, it gets multiplied by a factor of 1 plus 4 by 5, 9 by 5. So the new expenses are 9 by 5 times, or simply that the ratio is 9:5. So if the current expenses are 9y, then the previous year expenses are 5y. While his savings grew by 60%, 60% growth is 3 by 5 fraction, 3 by 5 fraction. So it becomes how much times, what is the multiplying factor? So I'm basically using the multiplying factor concept, right? So 1 plus 3 by 5, 8 by 5, or the ratio is 8:5 between the current year and last year's savings. So if this is 8z, then this is 5z. I have taken three different independent variables because as of now, to start with, to analyze the given statements, I have to do that, right? 3x becomes 5x, 5y becomes 9y, 5z becomes 8z. Now comes the important point. As I have said this already so many times, that income is expense plus savings. So in both the years, the last and the current year, we can write the equations between these three variables, which should help us to finally then conclude the problem, which means last year income 3x should be equal to the 5y plus 5z. The total of expense plus savings is the first equation, and this year's current year's income 5x should be equal to the total of the expense and savings 9y plus 8z. Hopefully this should help me to reach to the answer. I have to find what percentage of his salary does Hari save now. So I have to find basically 8z is how much percentage of 5x. So since I have to relate a z and x, I think I need to eliminate y. So let me eliminate y, right? Let me rewrite the equations in such a way that 5y equals 3x minus 5z from the first equation. I have just rewritten, right? And from the second one, 9y equals, this goes over there, 5x minus 8z. And now I will divide these two equations and I'll get rid of the variable y. And now I'll get the ratio of x and z that will help me to get the answer, right? So I am cross multiplying 5 into this, 5 into 5, 25x minus 5 into 8, 40z equals 9 into 3, 27x minus 9 into 5, 45z. So I'm getting 27 minus 25, which is 2x equals 5z. 45 minus 45z. So finally, I have to find that 8z, his current year's savings, is what percentage of his current year's income, which is 5x. I have to find 8z is how much percentage of 5x. So this into 100%. 8z by 5x is 8 by 5 into, from here, z by x is 2 by 5. So this becomes therefore 16 by 25 in fraction terms, which in percentage terms, yes, it is 16 by 25 into 100 is 64%. Right, people? So something new, even in arithmetic, right? There's scope for something innovative always. And that is what I want you to be exposed towards, right? New style, new ways, right? Old wine in new bottle, as the saying goes. Okay, so I hope this was fun, interesting, and that you would take this ahead and use this, right? And this becomes another set of questions, right, for you which you have now become exposed towards, some new concepts perhaps you have learned forward, right? So that's it, people, for today's session, right? uh, and I hope to see you again next time. Sir, can you repeat logic of question 6? Okay, question 6. Right, Shubham, I'll do that. So Shubham, in question 6, what happens is the other 5 people do not have any restriction. Apart from CM, MLA, and governor, the other 5 people, they can be freely arranged in this 5 factorial, which is 120 ways. Right, Shubham? And CM is already fixed, clearly written, he must open the floor. So there's nothing to arrange about CM. He's already always the first person. Basically, we only need to arrange the remaining 7 persons. As far as MLA and governor are concerned, I have just framed the options for them. So between CM and MLA, there need to be at least one person. So MLA can never be the second guy to come to the floor. He can be third and onwards. So every time what I've done is I've fixed the MLA's option, which this is his position numbers, right? Position number 3, position number 4, position number 5, 6. And correspondingly, then for the governor, because then governor also must come at least one speaker between MLA and governor. So therefore, if he's third, he can't be fourth. So he can be fifth, sixth, seventh, eighth, 4 ways. If he's fourth, he can't be fifth. He can be sixth, seventh, eighth, 3 ways, and so on. So that gives us total of 10 ways for these two people combined. And that 10 into 5 factorial is therefore your answer. Right? Okay. So I hope this was fun, interesting, right? Looking forward to see you again, right? I had fun, and I am very happy to see your response, right? First of all, kudos to everyone in the session for a very good response, right? So with the promise that we'll meet again with similar agenda, right? I will therefore be looking forward to the next one with you. Fine. Thank you, everyone. Thank you, everyone. Career Launcher mobile app is here, right? It's one of the many ways to connect with us. So make use of it if you are habitual of, using phone and devices also to, study. So we are also now having our mobile app. It has been recently launched. So make use of it as a part of your learning process, right, people? All the best. Thank you, everyone. Thank you so much. See you next time. Right. Thank you.